Thank you, John. Thank you all for coming this morning. I guess the last folks cleared out of the dinner at 11 o'clock last night, but maybe still an early morning. So I appreciate having the audience here with me. What I want to do in the next hour, or actually 45 minutes, is basically to give you a sense or a feeling for the security development lifecycle. I've talked to folks yesterday about the conference, about the attendees, and about what people's interests are, and the understanding I've gotten is that people here are going to have some familiarity with the security development lifecycle, with the SDL. Maybe not having read the book as John has, but an understanding of it. So I'm not going to go back and sort of recap things you already know. What I want to do is give you a sense of sort of what we did, what we do, how we did it, what some of the dynamics were, and then my objective is to leave 10 minutes for questions before the 5 minutes for Dennis at the end of the hour. So and I'll be around here most of today. So if you don't get a question to me during the the question slot that I allocate, catch me during the course of the rest of the day. If you can't do that, slipner@microsoft.com, and I'm happy to respond to emails or ask other folks about questions I don't know. I want to say a word. John sent me the link to the OWASP website and the commercialization policy and the speaker agreement. I want to just say a word about what I'm doing and not doing. We built the SDL at Microsoft. I'm going to talk about examples from Microsoft and how we do it, because that's what I know mostly. I'm not trying to sell you anything. I'll give you some links to some stuff that we give away that you can download and use if you find it useful. But definitely not a sales pitch. So what I want to do in too many slides and too little time is cover the topics shown on this slide. Some of the background, why we felt we needed to do something about software and software security and security assurance, how we sold the process, how we sold the security development lifecycle internal to Microsoft. I think that's sort of interesting because people have asked me, how do we get support in our organization to do something like that? I want to talk a bit about the SDL at Microsoft, just a very quick introduction to what the processes look like. I want to talk about managing change and the book, what it's good for, what it's not good for, how we've updated and adapted, and how we continue to do that, and then the role of automation. I'm going to go fairly quickly through the actual description of the SDL using something that we've made freely available from the website, the simplified SDL, which is sort of the generic process that we've released in the hope that organizations that wanted to emulate the process could use it. Talk about objections to the SDL and some of the things that we believe about what we hear about it, and then if I have time, I'll go through some of the free resources we've made available and wrap for questions. So how we got here. What I tell people when I talk, in public often is that is that I was hired at Microsoft in 1999 to run the Security Response Center, the organization that deals with externally discovered vulnerabilities in Microsoft products. And that when I was hired at Microsoft in 1999, I was 34 years old, okay? You have to look at me and think about how old that would make me now, and what that security response experience would do. That's supposed to be a joke. All right, not much of a joke. But the reality is that I started working in computer security in late 1970. So I'm closing in pretty fast on my 40th anniversary in the field. When I started doing that, we were worried about building time-sharing systems that could protect government information from hostile attackers with programming access. And we built, we did demonstrations, we did, what you'd call penetration tests. Now, give me local access to a time-sharing system, and I can actually, and I can gain supervisor mode or kernel mode control, sorts of things that people do, that people still do. And we built some mathematical models and some theories about how to build systems that would that would resist those attacks. But back in those days, there weren't any real examples to convince people that the problem was real. What we saw was either no computer abuse at all, or else cases where insiders with authorized access abuse their access. There's a guy who used to work for a competitor of mine in a later life who used to say, accounts receivable steals from accounts receivable, and accounts payable steals from accounts payable, and nobody would ever take a system with sensitive information on it and connect it up to an open telephone line or network. So that was the prevailing wisdom up through about the mid-'80s. And so security, very much a theoretical problem. We came up with ideas where you could formally verify security, build a software, prove it's secure, you're done forever. Interesting that some of those ideas have come back. I was reading in the communications of the ACM on the plane over from the US about some folks who've actually formally verified a microkernel written in C, a research group down in Australia. So things just come around. But in the 80s, that wasn't the time. And so, people didn't build products, projects were canceled, not much interest, not much success. Until the internet, and the internet, as all of you know, changed the rules and the reality. We started to see viruses, which were sort of a special case of what we had defined as Trojan horses. Some of the research in the early 70s. We started to see information shared. We started to see the kinds of connections that people said wouldn't happen. As you hooked your web server up to your commerce backend or your accounting backend and to the internet on the outside, and the barriers came down. I worked in the 90s for a firewall company, and we built this, pretty flexible, powerful firewall product. But basically, everybody had to let port 80 through, and everything rode over port 80. So that model wasn't so great either. By the mid-'90s, of course, vulnerability research for reputation, and it was the vulnerability research that led to security response processes and the Security Response Center that I did in fact run for Microsoft from 1999 to 2003. And so the first thing that we felt like we had to do was to say, okay, at least if people find problems in our software, we're going to fix them. And that's still not a bad thing. That's still not a bad thing to start with for an organization that doesn't have any security program at all. If somebody finds a hole and says, and says your software is vulnerable, you need to answer the phone or answer the email and be able to do something about that. People ask, what should we do to get started? That's one of the things that we tell them. We also, something that's less well known, created in 1999 something called the Secure Windows Initiative. And that was a group that was supposed to address, tackle, solve this problem of software, of security assurance. And the way that was to be done, the part about my being 42 years old was a joke. This is actually serious. We took 3 program managers, Michael Howard was one of them, and they were assigned to review all the components in Windows and file bugs for any of the security problems that they found. And then the development organization of thousands of people would fix those bugs, and then we'd have a secure product, okay? I mean, that was the initial approach that Microsoft came up with in 1999. That evolved by 2001 to an approach of team training and what we called bug bashes. Basically spend a morning training and then spend an afternoon doing code reviews or doing testing, finding security bugs and filing bugs to fix them. And that was sort of the process when I took over the security assurance role in mid-2001. And with that process of training and bug bashes and filing and fixing security bugs, we thought we'd done better with Windows XP. And in mid-2001, many of you probably remember this, we had Code Red in early August. We had NIMDA in September, and then we had something called the UP&P vulnerability, which didn't lead to a worm or exploitation, but was a pretty bad vulnerability that was discovered in XP when it was like 2 or 3 months old. And so, by that time, it was evident from what we were hearing with from our customers that we had to do something. And the do something took the form of Craig Mundy who's one of our chief technology officers, working with Bill Gates to draft and send the trustworthy computing email that said basically we're not going to allow this to continue. We're going to do what we have to improve the security and privacy of our products. That was a super important thing for reasons I'll come back to. In parallel with that, the team that I led at the time was trying to figure out, okay, is there anything we can do to make some improvements relatively rapidly? And what we came up with was the idea, well, we'll just stop all of Windows. Not this business of take people offline for a morning for training and half day to file bugs, but we'll take them offline for a significant amount of time, train them, and then get them to do the things we know how to do at the time. And those were threat modeling, and I'll come back to that, code review, running the tools we had, conducting tests, and I'll come back to that, and changing the product to make it more secure by default. We thought that would be a relatively quick way to significant improvement. Some fun stories about that. I talked to the program manager who was responsible for the release of Windows Server 2003, which is the Windows version we had under development at the time, and Michael Howard and I met with him. Said we wanted to do this, and he said, well, I think we could arrange that, probably fit it into the schedule. I'm thinking of a half day for training and a day and a half for the actual security push. And we said, well, we were thinking of a little longer. And we wound up getting a commitment for a month